maybe wearing ZKV hoodies, come and speak to us to find out what we do. But what brings us all together from different areas of the ecosystem is to support privacy in ZK tech. And we do that in quite a few different ways. So we, of course, run events like this, and we've done series like this over the last few years. We run validators, but we also try and advocate for privacy in ZK in all sorts of different ways. That includes getting conversations going in smaller groups with different members of the ecosystem, governance, building sometimes tech tools, which we release open source, and also launching and funding initiatives through grants processes and other ways to help support builders.
And so just to describe a few more of these initiatives, we research and publish educational material. I really recommend you check out our blog. We just released an article kind of comparing different private DEXs. So we're doing a lot of work in that direction. We also do early stage funding through investment or grants. We have, in the past, we've actually been kind of the not creators, but like co-leaders of the Gitcoin ZK Tech side round. And we're also supporters of the Z Prize initiative. And then we do network-focused events like this one. So recently we did an event with Osmosis focused on MEV, as well as Evmos and bridges. So often we're trying to find like a very important topic that has some ZK in the mix, and then working with those networks to build more, to sort of get a conversation going. Quick little announcement, we're actually doing an event in Paris called ZK Paris. We're co-producing that with Geometry, so just a note if you're there. And also I really recommend you check out the Cosmos newsletter if you don't already know it. It's weekly, and Hector's actually picking 3 important topics in the Cosmos ecosystem. For me, it's an amazing briefing. I hope you check it out. And so why this event? So we've believed for quite a long time that privacy is the next frontier for Cosmos. And why do it now? Well, the network is definitely at a pivotal moment, and I think having this conversation is important. The number of projects incorporating privacy still remains small. So we've actually been running these kinds of events for, I think, 2 years. And one of our goals was very much to encourage more development. We've seen a little bit more development or incorporation of ZK, but we'd love to see more. Just a note, we were thinking about it, it's our 6th time that we do a privacy in Cosmos event, 2nd time IRL. Last year we had actually received hub funding for 4 events. This time around, we just felt like there was a lot that we got out of that, and we wanted to continue this series, and so this was by the ZKV team. But so the goal is to bring together the Cosmos community, the privacy community, and the ZK community for a larger conversation, and hopefully get more projects using ZK in the future.
So we've got some fantastic featured projects talking today. I think this time around, compared to previous events, there are more privacy-focused teams, so that's great, who are kind of coming into and building this space.
So a little housekeeping. This is the Impact Hub. Just to give you sort of a sense, if you're just arriving, this is the main hall. We have the ZKV Rockaway Lounge over there. We have a relaxing room over there, and there's a terrace if you go through the door. The whole schedule for this event is viewable on our website if you just do /privacy in Cosmos. And also if you see there's a banner that will lead you to the Eventbrite link, and the schedule is also there. And I think we're just running it here, so you can always check it out as well. This is the Wi-Fi. I believe there are signs everywhere, so it should be very easy to get on.
So the event format is going to be relatively informal. We've got 4 talks, 2 panels, and then a lunch. And then after lunch, we're going to have open discussions. We'll talk a bit more about what that looks like, but we're trying something a bit experimental this time around.
So for the agenda, as mentioned, we have our intro right now, 2 talks, and then a panel on ICS, Mesh, IBC, and privacy. We're going to have a short break after that. And then in the afternoon, again, we have 2 talks and a panel with external privacy projects coming into Cosmos. Then we break for lunch.
So after lunch, we're going to have an open discussion. And we wanted this to be, I think, particularly because of where Cosmos is right now, about the future of Cosmos, as well as privacy and ZK. And we're going to, depending on how many people stick around for that, split up into groups, work on some questions about what is the future of Cosmos, how can we solve some of the challenges it's currently facing, and then come together into a sort of open roundtable format to discuss through those topics. I think it's going to be really interesting to try, and I hope you'll really enjoy that.
Yeah, and maybe just before lunch, we can share a little bit of the topics that we want to cover, because, I mean, there's so much happening even this week, and we felt like this could be a really good forum for us to have a conversation about that. All right, so yeah, thank you so much for coming to our event. Very excited to spend the day with you. You can follow us on these various websites, see us on Twitter. You can actually support us directly if you stake to any of these networks. I think we're missing one, maybe. Also, if you do tweet at us, I just want to, I hope I'm saying this right, Hector. If you tweet at us, so we have this there's like a ZKV swag box, which is like the coolest swag altogether. And so if you send a tweet, find Hector, maybe let him know that you've done that, and we're giving some of those away. Cool. Yeah, thank you all for coming out, and very excited to spend the day with you. Here's our first, oh yeah, let's clap. Thank you. Oh yeah, so first up, we have Zaki. Where are you? There you are. Giving a talk on the unbearable weight of sovereign multi-chain UX. Exciting.
Cool. All right. I guess sort of like the theme of talks from me lately has been UX. And UX has been on my mind because growth is on my mind, both growing Sommelier and the challenges of like onboarding new users, primarily from ETHland into an application. But I've been basically doing a lot, like because of Sommelier and other activities, I've been very much more on like the application side of of Cosmos and the blockchain ecosystem lately. And like what I have become much more aware of is like the incredible challenges of building like a user experience that can like onboard users in any meaningful scale, and how hard these problems are. So just a little talk about, like, this is gonna be a quick talk just about like challenges that I see, and like not necessarily proposing solutions, but encouraging people to think about them more. I also would just say that like essentially Cosmos, growth for Cosmos at this point is existential. You know, I would say most of our sort of monthly active user numbers have been flat for the last year. And if we don't change that in the next year, we are not going to be around. So basically, the sort of general theme about things that will improve in like the UX in Cosmos is, one, we've had account abstraction through Auth0 in production for almost 2 years. But like relatively limited uptake. And so like, why is that? What can we do about that? IBC middleware is becoming more and more of a thing. I think like one of the more interesting UX things that recently shipped is Stride doing one-click liquid staking. So like basically you start the liquid staking process, but then all of the subsequent transactions are delegated to the IBC relayer to complete. And then there's this like the magic word of the moment, intense, which I'm mostly not gonna make this an intense talk. So what are our challenges? Gas has been like sort of a never-ending challenge for the Cosmos user experience. Kepler recently shipped like making it easier to use alternative gas. Gas UX could be improved. A lot of it is just social coordination, like agreeing on coins that can be used as gas and coordinating all the validators and the and where needs to be governance to support a single gas token. It's still like a complete nightmare to like manage hot and cold wallets. Multisigs are like the native Cosmos multisigs are still very like non-native to the ecosystem. Signing multi-step flows where you have to do deal with like various latencies are a complete nightmare. So like I want to bridge from ETH to from ETH via Axelar to Osmosis and then do something is like you wait 20 minutes and you do step 1, you wait 20 or 30 minutes and then you do step 2, and like it just shocks me that anyone would do this. And then whenever anything fails, like failure and recovery is like an even longer and more complicated process. Like I find it hard, and you know, I have the whole architecture of the system in my head. And then privacy is going to make all of this like much, much worse. So it introduced off-chain state, viewing keys. Basically, every Cosmos chain has been running the same staking and distribution implementation, and privacy basically inherently brings us multiple implementations of staking, and generally like overcoming like the down-only tokenomics of Cosmos involves building multiple implementations of this. So from like a wallet and a dashboard point of view, instead of having like 45, 50 index implementations of exactly the same software, now we're going to start seeing more and more divergence in these systems. And then we don't really know what the practical trade-offs are. Like MetaMask snaps seem to be like one of the most important things happening in Cosmos, but like what are the practical trade-offs between like using a snap and a dedicated wallet like Kepler or Leap? So things that confuse me are like I don't know why Cosmos wallets don't come with like a built-in bot interface that like or like first-party bots that come from the wallet providers that just will automate things. Like I don't know why like YieldMost is a separate thing from Kepler. It probably shouldn't be. I think wallets should charge like monthly fees. I think like the wallet monetization model is so far been basically like pay us as a first-party project to like to get like user reach. I think we need to like definitely be moving more to like where wallets have like direct relationships with their users. And I think I left off the last, but we'll forget that. Then other thing is like session keys. So like one of the other things that we could be doing a lot better in Cosmos is rather than like you use Stargaze, I'm going to like make a bunch of transactions. Why do I have to like sign with my hardware wallet for every single thing that I did? I just want to bid on NFTs. Like we should be doing more about delegating restricted capabilities to. This is another basic use case of our Auth0 stuff, but like especially in the sense of like privacy-enabled applications as well, right? If we're going to be using like different cryptography, different like that may or may not have ledger support, like how are we going to do that without being able to like delegate restricted functionality to like sort of more short-lived keys? And then finally we have like the sort of meta thesis, which is that like topologies in a single chain world are really hard. Like how do I get from like I want to use an app that takes WETH, and I have like a bunch of different liquid staking tokens, a bunch of like other tokens. How do I get there is already really hard because like swapping, pools, liquidities, slippage, depth. Now when you add on top of that like multi-chain UX, this becomes a nightmare. So basically the reason I have been running around intent pilling people is probably multi-chain UX is going to run into fundamental barriers until we get to the point where we have an intent settlement interface like what Anoma is working on. But that generally seems to be like where we eventually go. But I think what we see in like the sort of IBC middleware world is like an early form of intents sort of expressed by stuff like Squid and like the Stride example that I gave before, where like you can delegate work to IBC relayers. We do have searcher markets, like Skip does exist, it does have a searcher market. We do have this IBC relayer market. Like these things do exist and like need to be extended and leveraged to improve UX. So thank you very much.
Thank you, Zaki. Are there any questions?
Yes. Okay.
So it sounds like a lot of what you're talking about would be addressed with if there was more competition on the wallet side. And I mean, maybe that's not all of the problems, but don't you think, I mean, basically, do you think there's a specific enough effort to give more grants to create more wallets that maybe then compete on these different aspects on the UX side?
I guess to me the question, so like, I guess I didn't, like okay, so my question with this is it's like, so wallets have been like the wallets have pursued models where they're like, hey, like we're gonna be like a least common denominator over a lot of different things. Like that's basically been the wallet model. But like sovereignty means like a continuous drift away from least common denominator. Like like the other example that like is there is like, so like the primary difference between like Evmos and Polaris, which is the Berachain EVM fork, is like Evmos is like, let's have a bunch of Cosmos SDK message type and then have an EVM message type. Polaris is like, there's no Cosmos SDK message types you ever really interact with. You just interact with the EVM. The Cosmos SDK is a layer that sits underneath an EVM for like doing Cosmos-y things. But that means that like the least common denominator among like Kepler wallets like just like isn't gonna work. Like you're not gonna be able to see your staking and delegation. And even then you wouldn't be, like it's not the standard Cosmos staking module anymore, right? So like I think we have like a real challenge that like is gonna have to be explored, which is like, what is the right way of even constructing wallets into this world? Because like the answer might just be that there's like a Berachain staking snap, and that's the answer, right? And like the least common denominator, like wallet support all the same thing just like doesn't work. And like the same thing is like how do you get privacy support into Kepler is like sort of like a completely unanswered question.
Hey, Zaki.
Hey.
We've been exploring some cross-chain UX stuff that is salient to this topic, and in particular, we're trying to do like multi-chain flows where we want to make sure that the funds are recoverable in the middle.
Yep.
And one of the things that we're running into is basically alternative key derivation paths on different chains.
Yep.
And the complexity of this just explodes when you get into like the session key world.
Yep.
And I don't know how to kind of square these two. It's really important for multi-chain automation to be able to have user custody across all these different chains, but we're kind of like moving further away from that with.
There are like BIP30, so like HD path thing is this like hierarchy of hashable values, and there's probably like, so like the origin story of this whole sub-key thing, like I will briefly digress and hopefully be like is. Like, once upon a time, the Trezor people and the Ledger people came up with a standard, which they were like, okay, our access control mechanism is like different blockchains will have access to different subtrees in this like giant Merkle tree of like private key values. So you'll have your mnemonic at the top, and then you'll have different subtrees. One thing that like is sort of an interesting question that is like how I think we should probably be doing session keys is basically have like a subtree for session keys, right? And so you could have some sort of local thing that like gets the root of the subtree value on your local device and then passes it into a less secure environment. So you never use that like subtree for like high value key storage, but like you could use that subtree. But like basically it would be like turning the like ledger, like Trezor access control mechanism a little bit on its head, and using it for like non-hardware key storage, and then having like applications that can like, it's always like the general policy should be like, we could even have a ledger app that like derives that session subkey and like makes it available to the app. So there's stuff that we could do there. It's like a bunch of coordination overhead, The alternative is just like separate mnemonics for like separate session keys and like long-term storage keys. Good.
Any other questions? Okay, thank you very much, Zaki. And now I would like to introduce to the stage Finch from Penumbra.
Hello. So, today I want to talk about this thing that we've been calling full stack private protocol design. Because, all right, so I'm from Penumbra Labs. This is our logo. It's the best that I can do, drawing it by hand, because I decided to draw my slides by hand because I thought it would be fun to do. So I'm from Penumbra. Those of you who don't know what Penumbra is, I'm just going to give a really quick overview so that I can ground the talk and chat about some of the cool stuff that we're doing. This talk is going to be a bit of a grab bag, and I think that's going to be really fun. But the grab bag has a theme, and I will introduce the theme momentarily. But first, so what is Penumbra? Penumbra is a Tendermint L1 app chain written in Rust. We have shielded transfer, staking, governance. As Zaki was just saying in his talk, all of these operate on a model that is different from the Cosmos SDK, which means that interoperability is kind of an interesting question. I was just having some cool conversations about private interchain accounts and how we can make that work with the Penumbra model, which is not an account model under the hood. It's a UTXO model, like Zcash. Accounts from the user perspective are sort of a polite fiction presented by the client interface. But that's sort of an aside. Also, we have IBC, to and from anywhere. And so you have this interchain shielded pool that Penumbra gives you in the Cosmos ecosystem and beyond. As well as in the center of that, a shielded DEX that uses a lot of the really cool privacy features that we've built in Penumbra to get some really unique features of a DEX, stuff you couldn't build without privacy in that environment. And I actually give a talk about that at Gateway on Sunday morning, very first talk slot of the day. So some of you may not have seen it because you were asleep. And that's fine, because it's recorded and it's on YouTube already. So you can go look it up and watch it. And I encourage you to do so. It got some good reviews. So this talk is about three things. When you're building a private protocol and you want it to be used by people, like actually used, you want it to be faster, easier, and cheaper than everything that has come before. Because if your private protocol is slower, harder, and more expensive, then no one is going to ever use it, regardless of how much they care about privacy, except for weirdos like me, right? So, and probably quite a few of you, but we are weird, right? We're not the norm. So I want to talk about this. This is a shitpost that I made recently. I was talking to the Penumbra group chat that we have inside the company, and I had this like little brainworm. I was thinking about some of the different architectures that we have in Penumbra, and I realized that we've got these different structures that represent different parts of our flow. So we've got something called a transaction plan, which you can use your human intent and what we call the view service to construct. And then this gets turned into a transaction. So the plan is like the plain text version of a transaction. The transaction is the encrypted version. Then once you submit the transaction to the chain, what you actually look at once you pull it back down from the chain is a transaction view. And then sort of hypothetically, you could translate that back into a sort of abstract representation of the human intent behind that thing. And I realized this 4-element cycle looks exactly like this thing called an OODA loop. And those of you who are not familiar with an OODA loop, it was this idea that got invented by some guys in the Department of Defense or something back in like the 1960s or something. Don't quote me on that. But there are a lot of memes about this. There's this very funny Twitter account called Defense Charts that makes that sort of posts declassified slides from Department of Defense briefings that look like absolutely insane PowerPoints on drugs. And so like I sent this to the group chat and everyone was like, this is a great shit post. We should post this on our alt account, which is called Penumbra Devs. And so we did that. And then I started thinking about this and realized this is actually not just a shit post. This is actually kind of an interesting way of thinking about the way that private systems work. This is an example of what we call shitpost-driven development. And it turns out shitpost-driven development is actually a really great way to figure things out for real. Because when you're shitposting, you don't restrain yourself to just thinking in a sort of like orderly and straightforward manner. You let your mind just cast out for associations. And oftentimes what that means is that you realize that there are certain symmetries that manifest as jokes, but are real. And when symmetries are missing, you realize that there's something missing in the design of your system. So I am like full-heartedly and unironically in favor of shitpost-driven development. I encourage you to try it out. And I will see you on Twitter when you do that. So anyhow, this OODA loop, I'm going to talk about sort of all the different components of this flow and how when you when you're constructing a private protocol like Penumbra, you have to think about how to make it faster, easier, and cheaper. Not just at one part of the flow where, say, perhaps you're processing a transaction on the node, but also where you're viewing a transaction on the client, or you're planning a transaction on the client. Like there's this whole loop that goes from the client to the node, and then back again, maybe through a relayer, does all sorts of stuff, right? Okay, cool. So faster. And this is where we get into the grab bag stuff. Most clients, most of the time, they're not sending transactions, actually. And I gave a talk about this at ZK Summit 8, which has some pretty cool visualizations that I did not draw by hand, but wrote a computer program to generate. So you can watch that with more details about this. But they're actually doing private state sync. That's to say that when you have a ZK system, you can't just query the chain, of course, to find out what your balance is. You need to download the entire history of every transaction that's ever happened. And you need to decrypt it locally. You need to synchronize a shielded commitment tree in order to get the root hash so that you can prove inclusion of all of your state fragments, right? So this is slow and hard because you have to hash everything from the beginning of time into now. So we didn't want to do that. Instead, we built this optimized, tiered, accelerated Merkle tree that we call the tiered commitment tree. That's what my talk is about at ZK8. But we also realized that this isn't enough because fundamentally, even though this solves the computational problem of not having to compute every hash since the beginning of time, you still have a bandwidth limitation problem because you still have to download every transaction since the beginning of time. So we built into Penumbra some cool cryptography to do fuzzy message detection for private delegated scanning. So what this means is in your like key hierarchy, you have a particular subkey that's called the detection key. And the detection key is something that you can hand off to a third party, not a trusted third party, but just any third party, and say, hey, can you please scan probabilistically for all of my transactions? And that party will hand you back a set it's like an encrypted Bloom filter. So that party hands you back a set of, say, 10 times more transactions that are actually yours. And then you locally filter those down. And the third party can't tell the difference between the transactions that are yours and the like chaff that's generated. So it still more or less protects the metadata privacy of the transactions that you're doing because the third party doesn't know which is you in the like restricted stream that it's filtering out of the fire hose. But you get to download only 10 times more data or whatever, like a factor of 10 I'm just sort of like waving my hands about, as opposed to the entire fire hose. And that's really cool. And that means that you can take even better advantage of the optimized accelerated Merkle tree that we have so that you can just like zip right ahead and synchronize your entire state so that you can use the wallet on your cell phone or something like that. All right, so. But sometimes also you don't just want to know how much money you want to have, you want to actually send that money somewhere else. Weird, right? We also want to make this fast. So we realized that when you are authorizing, when you're constructing a transaction, you're sort of doing two things at the same time. You are proving the transaction, you're forming a zero-knowledge proof, and you're producing the witness data that's necessary to create that proof, but you're also authorizing the transaction by signing it. Now, signing the transaction is a pretty quick thing to do computationally. The proving actually takes quite a lot of time, by which I mean like less than a second for a lot of our Penumbra transactions, but still, yeah. So, but you're also authorizing the transaction. And so what we did is we said, well, do these things concurrently. We architected things so that you can have a concurrent authorization flow, which means that you have the user say use their ledger device to authorize the transaction, and they simultaneously in the background you're doing all of this work on the computer to prove it. So that gives you more responsive UX. Okay, so easier, right? This goes back to the OODA loop that I had up there before. Intents, we're all talking about intents, right? This is not necessarily the intents that everyone else is talking about, but we do have this notion now of a transaction intent, and we want to build that so that we have like an easy representation of what does it mean to want to do something in a private context. Because these transaction plans that I've been talking about, they're the plain text of a transaction, but they contain all sorts of stuff like references to which notes you're spending, and randomizers, and ZK, not ZK proofs, but like you've got all of this like extra chaff that doesn't really represent actually what you're trying to do. It sort of represents like the implementation details. So instead, you want to be able to have a data structure that says, you know, I want to send like 10 USDC to ZK Validator because they're doing a great job organizing this conference, or something like that. And that's all, right? And then you want to be able to translate this into a plan so that this helps developers to write better interfaces so that they don't have to manage like actually building these transaction plans and scanning through note data and all of this stuff. But it also helps users to have a more comprehensible understanding of the contents of a transaction. So what about advanced users? What about advanced biddlers, right? So we've built the Penumbra state model in a kind of interesting way. So internally, we've got this way that we've got a copy on write state model. That means that when we are internally within the application, we're making modifications to the state. We don't actually commit those changes down to the underlying storage. What we do instead is we hold them in memory, and we've got like a layered stack of modifications. We can fork the state, we can do arbitrary things to it, and then at some point we can decide to commit it down. But if we don't commit the state all the way down, that means that we can actually just use the exact same mechanism to offer an RPC that says you can query a full node and ask it, what if I did this? What would happen? And it can give you a hypothetical answer about what if you did that transaction using the exact same transaction logic and validation stuff as if you actually submitted the transaction. Which means that for people who are doing like trading bots and stuff like this is actually like really useful. Okay, cheaper. Fees have to exist because we don't want people to be using up all of our network bandwidth, right? So we need a fee model, and there's this cool paper about multi-dimensional fee markets that we're going to be implementing on Penumbra. It's very cool. But we need a specific fee model within that kind of paradigm that's tuned for a zero-knowledge chain like us. In particular, we want to place a premium on any actions that contribute to the stream of things that you have to download when you are synchronizing your client state, because we want client sync to be fast. So as a consequence, we're going to charge more for actions in your transaction that don't just bloat the state on the full nodes, because full node operators have a bunch of resources, but actions that bloat the state that you actually have to download as a client, because clients don't necessarily have a lot of resources. But we realized that every Penumbra transaction is actually secretly, or not so secretly, a micro ZK rollup that consists of, well, the micro ZK rollup, that's to say the commitment and zero knowledge proof of a single transaction. We're rolling up a one transaction into one tiny little commitment to it, and also the encrypted contents of said rollup. And we thought to ourselves, well, why do we need two? Well, we need two because we want any client that has their seed phrase to be able to recover the entire contents of all of their state. And we also need the recipient of the transaction to be able to decode the notes that they have been sent. But what if you're keeping track of all of your own state off-chain, and what if the recipient is always yourself? So that's actually like a pretty reasonable scenario. That scenario happens a lot if you're doing a bunch of market making actively, because that just consists of like opening positions, closing positions, claiming rewards, all of this cyclically to yourself. So what if you could keep track of your own state and you don't, and you're only sending to yourself? Then you don't need to publish the encrypted data to the chain. You can just use Penumbra as a like micro ZK rollup chain for all of your trading activity. Well, that would be great, but you also need a way to durably track your own state. Because you don't want to lose that state, which means that you would make it unspendable. Like if Penumbra isn't holding all of your state, then that means it's not just if you lose your seed phrase, you lose access to your funds. It's if you lose your entire database of all of these tiny state fragments, which seems a bit scary, right? Because it's a lot easier to back up a seed phrase than it is to back up like a database that's in motion. So we're building Narsal. Narsal is a private or like a permissioned personal custody chain for Penumbra. It's based on Tendermint consensus, and what it lets you do is it does threshold keys. You do like threshold signing using it. You split your signing key across all of the shards of your Narsal cluster, so that when you want to submit a transaction to Penumbra, you submit the transaction plan for your Penumbra transaction to the Narsal cluster. It does and that is a transaction in the Narsal blockchain. And what it does is it signs the transaction and it gives you back the signed transaction for you to then submit to Penumbra. And that means that everything that you do on Penumbra using the key that's distributed across your Narsal cluster is itself tracked by the Narsal blockchain. So this is kind of an example of like, blockchains are useful for things even in a less adversarial environment. Like some people are like, oh, well, you don't need a blockchain for just keeping track of a database. You could just use a replicated database. Well, this is actually quite a useful replicated database. And so we just are going to use Tendermint consensus to keep track of all of the shards of data. And so you get threshold signing and you get keeping track of your private data, and as a consequence, what you can do is save on sending all of the encrypted bits to the Penumbra blockchain. So if you're an active market maker and you use this thing, you save everybody's work downloading all of your private state that they don't care about, and you save your own fees because you don't need to pay for the block space to store the encrypted blobs that you're storing locally in your own Narsal cluster. Right, so full stack private protocol design. How hard could it really be? Well, just do this. Think about all the bits. Trace all of your data through this. Think about how to make it faster, easier, and cheaper. And draw the rest of the Ouroboros. Thanks.
Thank you very much, Finch. Maybe there are some questions.
Yes, questions.
Anybody?
Yes.
I have a question that I wonder what's the practice content that you need to be approved by witness during a transaction, such as for instance, for the Zcash protocol, it managed to hide the transaction amount and the identity of the sender and the receiver. But according to your according to your presentation, your protocol seems to manage to hide the whole transaction, the whole content of transaction. So how to do that?
Can you repeat the last bit?
What is the what part of the of the context of the transaction you need to be put into the witness of the zero knowledge proof?
Oh, I see. So when we're witnessing things, the stuff that we're witnessing is the zero knowledge inclusion proof within the shielded commitment tree. So commitments to the existence of notes that you possess. So that's in spends. It's also in swaps, and in governance.
Oh, okay. So the commitment tree is consists of the hash value of each coin or some part of some unit of the.
You're proving that you have custody of a node.
Custody of the node. Node. And you mean which node? The node of the Merkle tree, or?
It's a yeah. So you're proving that that a particular note did get included in the Merkle tree, in the shielded Merkle tree. Yeah,
okay.
That's right.
Okay, I got it.
This might be one for offline, but as soon as I'm very interested in Penumbra using, interacting with other chains and using interchain accounts. I think I may have incepted Henry to push this forward. But the resource estimation seems like it's going to be very challenging. It's maybe not an issue now because it's all subsidized, but you're doing all of this work to multi-dimensional fee markets to kind of estimate the resource consumption within Penumbra. Mm-hmm. You kind of have a limitation that you don't want to call out to any clear text chain to understand the resources consumed there. Mm-hmm. What is the end game there if you want to interact with other chains and actually be able to estimate how that's going to be paid for?
Well, you're the one that incepted Henry to do that, so let's chat afterwards.
Yeah, let's do that.
But that's a really, really good question, and I'm super curious to figure it out. I do think we can do something there, but I don't know the details yet.
Any other questions? Okay, thank you very much, Finch.
Thank you.
And you noticed a slight change of the scene, so I'm inviting our panelists from Celestia, Skip, and Sommelier.
Have we got Zaki as well here?
Is Zaki somewhere here?
Test.
Okay, cool. So I think we've got a very broad panel title, which is just disappeared. But so ICS, mesh, IBC, and privacy. And I think most of those would be enough for a panel on their own. So we're going to try to maybe narrow the conversation a little bit. But basically, I think broadly we want to discuss shared security and how that's affecting the Cosmos ecosystem. And I think that's a topic which is clearly very important in and will continue to be for the next year for the ecosystem, and maybe touch on to how that is evolving and how it will impact things like privacy as well. So at a high level, the things in the title, ICS, Mesh, Celestia potentially as well, all have different benefits to builders who are coming to building Cosmos. And so I think just to get us kicked off, it would be great if you could each introduce yourselves and then also maybe say which part of that overall conversation you're most interested in.
I'm Sam Hart. I am the head of product and strategy at Skip, which is an MEV company. And I previously worked at the ICF for about 3 years. Not gonna lie, this is a bit of a scary combination of topics, but I guess one thing that I can speak to is I've done a lot of thinking about what security means, and in my mind, basically, that's there's several different facets. Really, you're trying to create some kind of accountability loop where there's like a form of verification and some form of punishment or way of enforcement. And with that framing, I think you can maybe like reason a little bit more clearly about the interaction between privacy and security.
Hi, I'm Gabriel. I'm a researcher at Celestia and team lead of Rollkit. I'm excited about shared security in the sense that rollups that are built on top of Celestia can use Celestia as a shared security layer. And it's interesting how by separating the stack into modular components, the things mentioned here, like interchain security and mesh security, can interconnect and use components of the modular stack to increase the validation. For example, let's say we use mesh security and they want to have objective fault to validate us that there was an invalid state transition function. We at Rollkit are developing fraud proofs for the Cosmos SDK. So mesh security could use those fraud proofs to prove to each other that, hey, this validator was lying, and slash them accordingly. So there's a lot of interoperability here. So it's very exciting to see that space.
Zaki, longtime Cosmos contributor, co-founder of Sommelier. I guess my overview of is that privacy fits really well into the sovereign app chain model with its own staking token. The concern is that what will liquidity look like for that staking token? And a lot of the so there's Namada is launching soon from the Anoma team. And it's like a privacy pool for the entire Cosmos ecosystem. But it doesn't really have any robust, let's say, native value accrual mechanism. And so, you could end up in sort of the situation where, Namada is securing a very large amount of value in the IBC and wider ecosystem for a privacy point of view. But the chain itself has very little economic security. So, it would be ideal to be able to use privacy together with, a shared security mechanism to make it easier to deploy privacy-related primitives. But there's also enormous challenges to that. A lot of these things leverage, the actually having a validator set for threshold encryption, et cetera. So it makes it hard to port that into a roll-up world easily. You have the reality that you're not running COSM, WASM, et cetera, on these chains, and the staking modules are different. So interacting them with ICS or mesh security is non-trivial. So it's what is going to be the common denominator there to sort of secure privacy-enabled apps in today's low liquidity environment is an interesting challenge.
Okay, yeah, some really interesting touch points there. Just before we dive into any of those, it would be great if someone wants to actually define, maybe for people who are less into the Cosmos ecosystem, what actually is ICS and what is mesh. Don't know if anyone. Okay, yeah, Zaki, go for it.
I can do it. So ICS, Interchain Security, is a product that is deployed to the Cosmos Hub right now, primarily developed by Informal Systems. And mesh security is a kind of variant or different take on a similar concept that is primarily being advocated by the Osmosis team and has a kind of collaborative group that's working on it. They're very similar. They are both forms of staking. So in the Cosmos Hub case, the Atom token is kind of reused or leveraged in order to stake on a secondary chain. And in the mesh case, there's kind of a bilateral or multilateral relationship between chains where both tokens are used to secure both chains. And there are some slight differences in the details under the hood in terms of how delegation is used and how the kind of stake is split up, how faults are accounted for and slashing works. But the general idea is that it's a form of staking that is used to economically secure a distal chain. And really it's the main distinction is this this kind of parent to child versus multilateral relationship.
Awesome. So I think maybe it'd be interesting to start back on the topic Zaki raised of actually if you want to launch, for example, a privacy preserving application, whether that's a private stablecoin or a mixer or something else, one of the issues you actually might face is that it's difficult to get enough security for your chain because you have low liquidity on maybe the staking asset, or maybe validators don't even want to run purely that chain because it exposes them to regulatory risk or anything else. So I think it's going to be particularly important for privacy-focused applications to look at these alternative security models. For each of you, what do you think will be some of the most what would be the most interesting model for privacy-preserving applications? And for example, with ICS, would current validators on the hub be willing to run these privacy chains in all cases, and how do you think that will play out? Starting, maybe Zaki.
Sure. I think all of these things represent big challenges and areas of uncertainty for the adoption of privacy in Cosmos. Is just that is probably the most straightforward way of looking at it. I think one of the questions would be is what's I think one of the things that will be there is essentially what API do people have to implement in their privacy enabled application in order to even potentially opt into one of these systems. So the consumer chain, which is sort of the child chain of and the security side, which is where a privacy preserving app that let's say wanted to use the Atom validator set would sort of live. It's probably a pretty simple API to implement on the whole. It's probably much simpler than let's say a staking module to implement. So maybe we'll see it's a lot that might be an initial low-hanging fruit, but then it runs into the political uncertainty problem, which is the political uncertainty problem is will the Cosmos Hub vote for these things? Will big institutional stakers Coinbase and Binance vote against it for regulatory reasons? And I don't think there's a single way to know until someone tries.
Interesting, yeah. One of the ways you could circumvent that if you don't need, for example, threshold encryption from the validator set is to try to build your application as a rollup. Because Celestia decouples data availability, consensus, and execution, you can focus on the application layer. So now new privacy applications have to bootstrap their own validator set and create, it's an overhead that hinders people to develop new applications and iterate and maybe go through governance proposals. And one of the other ways you could do it is focus on the application instead and build a rollup that is focused on privacy enabled through ABCI and like IBC, and delegate data availability and consensus to a data availability layer like Celestia.
Did you want to add anything? Or
so I have had a couple of conversations about, so one of the other challenges with a privacy chain is it is more difficult to fork in some instances. And forking is one of the primary accountability mechanisms of a chain. Basically, the threat of a fork kind of maintains some political equilibrium. So maybe I just add that this is like another dimension that needs to be considered, and it is one of the kind of the key security facets of a restaking system. So yeah, maybe we'll just kind of put that into the air.
Why is it hard to fork privacy chains?
Because you can't fork out a single balance. So if there's a misbehaving validator, unless you've pulled out their balance specifically, there's no way to kind of remove them from the token set.
Yeah, essentially like edited balances. Like, so like the notion of forking is like, to a certain extent, like there's this political threat that exists in transparent Cosmos chains, which is like, you know, the Prop 16 Juno threat, which is like, if social consensus moves against you with a sufficient amount of vigor, there's like you might end up on a sort of non-minority fork that doesn't, or minority fork that doesn't, and like the majority fork won't have your balance. But in a privacy-preserving world, there's no possibility of doing like Prop 16, right? Like you can't, like balances are all private, they're all hidden, no one knows, no one would be able to like easily to edit the state to remove. So on one hand, you get like stronger property rights from privacy, which is like I think a good thing, but like it definitely changes the like social equilibrium.
Cool. So it seems like we're in some sense waiting to see with some of these models, you know, and see them tested. We have seen Neutron now go live as the first sort of ICS chain using ICS. Have we learned enough from that? Have we learned anything from that? And what would we need to see happen in order to have more clarity as to how these different models might work together?
Some of the, I mean, it seems that like some of the concerns about, at least in the short run, about validators not running the Neutron chain, you know, that was like the biggest uncertainty with ICS was, right, would especially like sort of like the low, like there were two categories of validators who expressed a lot of, where there was concern was one, it's like the low engagement exchange validators, were they going to run the Neutron chain? And then also, you know, more regulated validators, you know, custodians, et cetera, who expressed concern about being forced to, you know, run a new chain that maybe wouldn't fit within their existing regulatory models. We seem to have at least, you know, made it to step one in that world, and that seems to have gone okay. And I think there's going to be a lot of uncertainty about this for quite some time. And like a privacy-enabled chain that gets through governance, I think will continue to we'll continue to ask novel questions.
I think it's maybe a good problem to have if we're asking that question. Like a privacy chain has been so successful that it needs additional security to ensure that it doesn't get taken down by a malicious entity. I would love to have that problem, actually. Yeah.
I think one of the other things that hasn't come up as much is like all of the we act as if like mesh, rollups, and ICS are like defined points, whereas what the actual reality is, we're going to see a lot more. There's a lot of possibility for recombinations. So like the existence of a fraud proof or a validity proof, it makes it a lot easier to, for instance, have like subsets of validator sets run a chain rather than having the entire validator set. So you could end up, like, especially in a world where like you have sort of roll-up friendly privacy a la like what Aztec is building. Like that kind of a system could be used to do a system that was like a subset of the hub validators run it, right? Instead of all, because it's like fraud provable state, but you'd still get a validator set and be able to do threshold encryption. So like not all, so like, all of these things can be recombined in new and interesting ways. They're not like discrete points that are like exclusive.
Yeah, and maybe it's worth, at this point, like teasing out, I guess, how I think about like a roll-up model versus interchain security or mesh security model. Like, basically, roll-ups put a lot of emphasis on the verification aspect of security. ZK roll-ups, you can prove that the state transition happened. And mesh security, interchain security put a lot of emphasis on enforcement. So if something happens, we can punish misbehavior. So there's actually a high degree of complementarity between these things. The fraud, an optimistic rollup is kind of a hybrid between these because there's an economic bounty in order to ensure verification. But it just kind of speaks to the expansiveness of this design space. Like you can combine these in interesting ways, and we can actually push quite far on the verification side of privacy chains by having light clients that verify the entire state, for instance. So there's different ways to increase your security level as a sovereign chain.
How do sort of data availability concerns tie into that problem if we want to be using light clients for example, proving slashing conditions between producer and consumer chains or any other sort of variant?
So with Celestia, you can delegate the data availability and consensus part, where a rollup can post their transaction data to Celestia, and the Celestia validators agree that those bytes exist. And if this rollup is also run by an ICS chain where the validators are producing the blocks for the rollups, then the data availability can be still on Celestia, and those validators would execute those transactions and produce, for example, the block headers. So you could have a combination of economic security that is fraud provable, or that you can have a validity proof on that. And like use both scalability mechanisms here.
Cool. So something to touch on towards the end. How will all of these, and how do you each imagine MEV sort of evolving in the ecosystem with these different types of models? Maybe it's a little bit too early to really be seeing how it will change, but do you have any sense of what that could look like? Maybe Zaki first.
Well, I mean, I think one of the most robust mechanisms for just eliminating MEV is having privacy, right? If the block proposer doesn't know what the transaction is going to do and can't simulate the future state transition, they can't really extract MEV from the system. So I think, or like some types of MEV can be mitigated and go away. There's definitely, there's still like being able to like adjust your like liquidity positions at top of block and stuff like that, which might which would be valuable. And I think the Celestia and the Rolled Kit teams have done like an enormous amount of thinking about different models and where MEV accrues there. Yeah.
Yeah. Skip has been thinking about this a bit. It's a little bit early, but as Zaki was saying, if you are hiding order flow, then there is less opportunity for economic leakage in those transactions. On the other hand, typically the decision to hide order flow has some trade-offs. You're going to be batching or introducing noise into the system, so just a set of trade-offs there. There's another dimension to this that we've actually put a bunch of time into, which is you very likely want privacy at specific points in the supply chain, really for accountability reasons. So, for instance, it would be helpful if validators are unaware of the incoming transactions at the moment that they receive a block, so they have no incentive to withhold that block and try to extract value in that way. So that can help with the kind of system robustness. Yeah, there's a lot of directions to go with this, but I think it's very early days, and privacy will likely play a role at various points in the in the flow from intent creation to execution.
Yeah, and one of the nice things about building this ecosystem in like a plug-and-play way, where one entity can focus on one thing and people can delegate that as a service, is also if you start looking into, for example, shared sequencers, where a roll-up will be able to delegate transaction ordering to a shared sequencer. And now how does the sequencer order those transactions? And do they maybe have some kind of MEV protection or acceleration, or like depending on who does what in what kind of way, you can increase or decrease MEV and redistribute it, which is very exciting because the modular design space explodes the moment you have very clear roles, and those roles can be explored in their own way.
Awesome. Thank you all very much for the panelists. I think it's clear that actually, in a way, it's almost a challenge because the design space is so huge to really explore all the different routes this can be taken. But the best thing we can hope for is that one or multiple privacy-focused projects actually launch and use these mechanisms and start to really give us clarity on how they should and can be used. But yeah, thank you all very much for your discussion. We now have a 15-minute break. There are tea and coffees at the back and snacks around the corner.
And also remember that we have ZKV Rockaway Lounge on your left. So there's some team members waiting for your questions. All right, so we are back with the talks. And I would like to introduce on the stage Nadim from NIM.
Hello, everyone. Thank you very much for having me here. My name is Nadim, and today I'm going to be talking about winning the crypto wars. I didn't come up with this title. It's a bit extra. But yes, we are going to be talking about interesting new technologies for enhancing the state of privacy on the internet in ways that are relevant for cryptographic and blockchain applications, as well as hopefully general purpose user applications. My job at NIM, which I started recently, is head of software integration, and my mission is to integrate NIM, the privacy technology that I'm going to be talking about, into as many different softwares as it makes sense. Stuff like Telegram, I don't know, Signal, secure wallets, and so on. Also, I am the author of a critically acclaimed puzzle adventure game called Dr. Kobeisi's Labyrinthine Laboratory. I brought a few copies with me. Please take a copy. I will leave them here. It's a very nice puzzle game. It's got over 100 levels, an original soundtrack, pixel art, stuff like that. I really care a lot about this game. I spent like a year and a half working on it. So I genuinely hope that you'll take a copy and try it out. It's available on Steam, Windows, Mac, Linux, and Nintendo Switch. But Nintendo would murder me if I tried to give a copy for free, so I won't. This is only for the Steam version. They're very strict, Nintendo. Their legal team is like the Yakuza. It's actually really insane. You should look it up. Anyway, so before I get fired for segueing into my video game, let's talk more about NIM. So the purpose of NIM is to deal more with the issue of internet surveillance. The thesis that we have here is that no existing solution can defend against the NSA and private companies and cyber criminals, well, like Google, Meta, and so on. Differentiating which one of those two go into companies and which goes into cyber criminals is an exercise left to the reader. We have some technologies, like for example, this clicker that doesn't work. I'm trying to click the button, but nothing is happening. It's not very effective, as Pokemon would say. No, still. Can someone skip? Oh, whoa. Nope, that's too many skipped slides. Okay. Could someone please go back to the previous slide? Okay, next slide, please. I'm just going to put this aside for now. All right, so there's a strong demand for privacy, which is why we're here. Tor itself keeps growing, especially when things happen around the world, like the Ukraine war or protests in Iran and other things. Also, Signal keeps growing, but the thing with Tor and Signal is that they lack what Nassim Nicolas Taleb would call an anti-fragile funding model. Namely, they're not resilient, rather, or they could be more resilient. Signal, which is an excellent contribution to online privacy, nevertheless had to be supported by an independent donation from Brian Acton, which is, one in a million sort of thing. And Tor has suffered from stagnating growth. Next slide, please. So our plan is to sort of offer a more decentralized and more incentivized mixed net that can provide better privacy than Tor, but also at the same time solving the resiliency, sustainability, and incentivization problems that may be faced by Tor or some other privacy-enhancing technologies. We do this with a token, and we also have some other technologies that I'll talk about in a bit, but first I would like to show you, next slide please, this comparison of how NIM is different from other similar technologies. So let's start at the bottom. When you're using a VPN, you're connected to the VPN, and your traffic just goes through the VPN and onto the website, whatever, Netflix that you're using or whatever it is. And there's no real anonymity happening here. You'll notice that these little dots, their ordering is the same. These are packets, their size is the same. Everything is the same, and the VPN itself, the VPN provider, can see all your traffic. VPNs don't really offer any anonymity, in my opinion. Tor is, of course, much better. Tor is a very nice technology that has actual onion routing. Packets are routed through a bunch of different Tor nodes operated by volunteers, and Tor has been very successful at helping activists and journalists and privacy-interested individuals over decades, I think. But nevertheless, packets can still be de-anonymized via their size and timing patterns. This is what we try to improve upon by using mixednet technology in NIM, which is an area of research that has existed for a while as well. It's better because it anonymizes the size and the timing of the packets. It mixes the ordering of the packets as well. To be fair, this leads to a slower service than something like Tor, but something a lot more secure, actually, in terms of anonymity. It can resist a much more capable global active attacker. Thank you for forwarding to the next slide. No, that was the good call, actually. So in our case, we have multiple hops, we have covered traffic, we have timing obfuscation, like I said. These are just, some of the technical ways in which we differentiate ourselves from existing privacy technology and hope to offer a better product to our consumers. Next slide, please. If you look at it from the perspective of the user, basically you're running the NIM client on your machine. We're using the Sphinx encrypted packet format to forward those packets through the mixed network, and then the mixed network throws the packets through the other side to the applications, services, friends, etc. And the service provider itself is free to run a service provider node, which interfaces with NIM for the user. And there's ways to get NIM running on the user's side. There's a way for service providers like Telegram or Signal to run NIM on their side as well. And so there's a diversity in the ways that NIM can be integrated across a stack, a product stack, or a network stack. Next slide, please. The NIM token is what handles the incentivization mechanism here. So when you run a Tor node, you're contributing to online privacy, but you're paying money to run the node, and there's no resilient incentivization mechanism that's happening there. But when you're running a NIM token, NIM mixed network, you're benefiting from the tokenomics present there, which are built on Cosmos, incidentally, because you are being rewarded via a proof of mixing. So there's a proof of mixing mechanism that looks at how much your mixed network node has actually, how much your mixed network node has actually mixed. And based on that, you get a token reward. So the more you mix, the more you contribute to online privacy, the more tokens you earn. And this hopefully will incentivize people to, and also establish a more resilient ecosystem for online privacy. The NIM token benefits the user because they can use it to access NIM. It benefits mixed nodes because they are rewarded for contributing to the NIM infrastructure and ecosystem. Validators, of course, exist to do what validators always do. You guys know about that stuff. And service providers, Signal, any other service providers, they can also purchase the token and provide it on behalf of their users so that their users can use their product with NIM for free. My job, like I said earlier, is the software integration aspect. And so I'm responsible for looking at how developers can integrate NIM into their products. One cool way that we're doing that is by offering a very nice set of SDKs. So we have a Rust SDK for NIM that allows to integrate NIM natively into any Rust application, get the cutting edge performance associated with Rust stacks. We also have a TypeScript SDK, which allows you to interface with a WebAssembly version of the NIM client in the browser. And that's also very nice because it means that you can deploy NIM in browser extensions in any Atom or Tauri or Electron app. No, Atom's the editor. Electron app, and in the browser as well. And we also recently started working on finished actually and published in collaboration with ChainSafe, a libp2p native transport for NIM. So you know how in libp2p you can specify the transport and it comes with a bunch of transports like WebRTC, WebSocket, and Quick. Well, NIM is the only libp2p transport that provides full privacy mixednet guarantees. It's the first privacy-preserving native transport for libp2p implemented in Rust, and you can check it out on GitHub today. That's one of the ways in which we're bringing NIM integration to the general public in more and more ways. So it has a simple, well-specified Rust API. It's very nice. It does all the things that you would expect are done when you have, good software engineering taking place, and all of that is there. When it comes to the users, we also want to make them more accessible to users themselves, like normal people who just want better privacy, not necessarily developers or anything like that. Right now we have this app. It's more of a proof of concept called NIM Connect, and it basically allows you to open up a proxy on your computer, and you can use that proxy to route Telegram through NIM and so on. But the idea is that we were going to expand NIM Connect to become the NIM app. So you just download NIM Connect on your computer, and then NIM Connect can detect, like, oh, you have Signal installed, you have whatever installed, and it'll automatically try to connect to these apps and route them through NIM for you. That's my goal, personally. I think it's a nice idea. We also have the NIM wallet, which is really nice, not only because it works on all desktops and it's nice user interface and so on, but it also has a good UI and UX for managing mix nodes. So you can manage your mix node from the wallet via a nice graphical user interface. You don't need to use the command line, even though your mix node is running on a server somewhere. Isn't that cool? This feature was implemented before I joined NIM, and when I discovered it, I was really excited about it because it means that not only trading NIM tokens, but also like just running a mix node, managing the mix node, all happens from one place. And that's very nice and allows a more integrated user experience for anyone who wants to contribute to the network. You can even monitor like the rewards that you're earning from your mix node and so on. We also have this thing, which I don't really understand how it works quite yet, so I'll skip it. All right, so just honestly, basically this is what I just described. You have the mixed node rewards that are being determined via a Cosmos smart contract, that's being validated by a bunch of validators, the way that many services on Cosmos work. Instead of cryptocurrency mining, we have mixnet-based proof of mixing mining, and you can stake your NIM in mixed nodes to basically give a vote of confidence to them, allowing them to route more traffic and earn more rewards. So there's a staking element in the NIM token and in the mixed node economics as well. And yeah, everyone is happy. I think this establishes an economic system where it works well for everyone. This year, in integration, we have upcoming work in terms of integrating native NIM support into applications. I had an encouraging discussion with someone here today who is looking at integrating NIM natively into a technology that you heard about earlier, and that's very nice. There's also going to be SDKs and layers for independent developers that just want to use NIM, and those exist already and are quite functional. And we also want to give users control themselves to just go ahead and download a NIM app and use it, right, without needing to deal with code bases and so on, because how will we reach the end user otherwise? That is going to be the ultimate test of the real-world viability of the technology and the product. Thank you very much for your attention today. NIM is a cool thing that you should check out. This is our website. Please feel free to send me an email. Make sure to hit like and subscribe, and stay tuned for more videos.
Thank you very much. Maybe there are some questions. Any questions? Oh, there are some questions.
Thank
Wonderful.
You. Yes. Yes, please.
Thank you. Do Mixnet node operators do they also have to be validators, or are those two separate roles? And if so, how do they sort of work together?
NIM mixed nodes and NIM validators are two completely separate roles. They run two completely separate Rust binaries. There's NIM-mixed node and NIM-validator. Anyone can run a mixed node. Right now, in order to run a validator, well, you can run one, but to be listed as a validator, you have to basically contact NIM, not me, someone more politically involved, to be listed. The rewards for validators are also slightly different, I think, and I'm not really sure how they work. But it's a significantly very different role, I think. There's no overlap. Sure. The gentleman over here, yeah.
Just a quick question, kind of related. Who did your token economics? They're pretty good, and that's kind of rare for infrastructure projects.
The token economics were done many years before I joined the company, which is about 6 weeks ago. To be honest, I don't know. A good person to ask would be Harry Halpin. And this is my personal thinking. This might be totally false, but I think that someone from A16Z helped, but I'm not sure.
Okay.
What are your thoughts on other maybe more established projects like iCloud Private Relay and their sort of like, techniques? Do you think being mass market is better than what you're doing perhaps?
Well, I think that iCloud Private Relay is a very successful project, specifically because it has it outcompetes us and basically everyone else in terms of being able to give a strong user experience, to integrate with the user stack. And that is something that in general, cool crypto anarchist, whatever technology fails at so far, hence why they hired me 6 weeks ago as head of software integration, right? So in that sense, yes, we need to catch up to them. However, strictly speaking, our technology is superior when it comes to the privacy guarantees that it can offer. And that's just how it is, right? Like if you study it, if you do statistical modeling, if you look at the cryptography, it's just better. However, can we make it as performant and as seamless for the user? That's something that the field has always struggled to do. And recently, it's been taking these questions more seriously, and hopefully it will continue to do so.
Okay, thank you very much. If there is any other questions, please ask them.
Yes, despite its eccentricity, the game was actually not a joke. So please come take a copy. I'll just leave them right here. Well, no, the speakers are going to be here. I'll just leave them on this table over here. So please take a free copy of my puzzle adventure game.
Okay, thank you very much, Nadim. And I would like to introduce to the stage Guy from SCRT. Okay, I think we need 1 minute for the game. All right, I think we can start. The game is there, so during the lunch, please take a copy.
Okay, hi everyone, I'm Guy. I'm the founder of SCRT. SCRT is generally a privacy-preserving smart contract blockchain. Essentially, it's your run-of-the-mill Cosmos chain with CosmWasm, but the key differentiator is that users can encrypt inputs, state can be encrypted, and outputs can be encrypted. So essentially, you can do all kinds of private computations. If there's one message that I think people here should take, is that privacy, in my opinion, and I've been in this for like a decade, is very misunderstood. So usually when you talk about privacy in Web3, it's always a discussion about, how to do private transactions, how to do anonymous transactions, how to hide your IPs, all like the conversation before me. These are all very important problems. But the problem is that when people think that this is all what privacy is about, it limits the discussion. So anytime I go like on a podcast, on a Twitter space, it always gets into this box of, should we allow people to anonymize their transactions, their IPs? What is the importance of protecting your own data? And how should we deal with regulators? Again, a very important discussion. I'm sure like half of the day would be about that. But I want to say that privacy extends it goes way deeper than that. In Web 2, we just assume that we have privacy. We just assume that it's built into our applications, at least in some form. Yeah, the big companies hoarding our data, but it's not that the whole world can probe in and see what we're doing. And in practice, if you think about Web 3, because everyone can see the data, there are many applications that we can't see, that we can't do today. Think about all kinds of games, casinos, poker, strategy, PvP games. All of those require some kind of hidden state that is segmented between the players. If you think about sealed bid auctions, generally people don't care about the privacy of their auctions. No regulator will come on board and say, oh, your bid was private, that is like, your money laundering. That's not the discussion. You need to do sealed deductions because they're more efficient, especially if we're going to start having things like MEV markets and all that. And there are many, many more use cases. And at Secret, really what we're trying to focus on these days is basically making it clear that these are the use cases that we should focus on. And with this kind of like umbrella thing called privacy as a service, we're basically trying to externalize it beyond Secret. Like you can do all of these on Secret today, but it's less interesting. I mean, Secret is a limited ecosystem. Cosmos is a much bigger ecosystem. EVM is a much bigger ecosystem. And those are really let's say, the domains that we're trying to kind of penetrate with this privacy as a service concept. Now, I'm not going to talk about all use cases. I'm actually just going to talk about one, which is more of a passion research project of mine that we launched this week. And I'm slightly going to touch a second one as well. So the first one is going to be Unstoppable Wallets. There's a research paper. If you want, I can give you the link. It went up, or just go on ePrint. It went up on ePrint yesterday. And then the second thing is basically on-chain randomness. And there are many ways to get randomness today in blockchain, but all of them are off-chain, and via Secret you can do it on-chain. So let's drill deep into Unstoppable Wallets. So wallets in general, I'm sure everyone here knows that, they're essentially private keys. You use a private key, you sign a transaction, blockchain has a public key, you can either move your funds, send them to someone else, use a contract, do something, some operation, or you cannot. But that is also a single point of failure. If you lose your keys or if someone takes it, you're done. So, there's this then idea of, okay, let's spread, let's not have like one honeypot, let's spread it around. Let's have a multi-sig wallet. How many people are familiar with MPC wallets here? Okay, so multi-sig wallets, how many people are familiar with that? Okay, so I guess I'll explain both. Multi-sig wallets are very simple. Instead of one person controlling the wallet, you have a group. It can be 8 out of 10 people, 5 out of 7, 1 out of 2, whatever you want to do it. MPC wallets are the same. They're a bit more technically sophisticated, actually much more. They have some benefits. The biggest benefit is that they're usually cross-chain. So whenever you have a multi-sig implementation, you have one for Bitcoin and the forks, you have one for EVM, and that's usually a smart contract and the forks. You have a different one for Cosmos, and each chain basically needs to roll out their own. When you do it via MPC, multi-party computation, you basically are building something that can go on any chain. The problem, and by the way, MPC wallets are generally winning the game. So like companies like Fireblocks, now Coinbase, all of those companies are basically, they're moving to operate in this way. You have the service provider here. They have like, one of the keys, and then you have one or more users that are co-signers. And that's how you get more security. So let's say I'm a company. I can sign up to Fireblocks. We generate this MPC wallet. They get half of the key. I get half of the key. Or I can do things like I have one half of the key, and they will co-sign with me for any transaction that is up to like $10,000. And then maybe there are 3 out of 5 people in the organizations that are able to sign on transactions that are higher than that. So the service provider acts as both a co-signer, but also as this like policy engine. Now, the problem with this model is that there's still a lot of trust in the service provider. So it's not as bad as like, going on a centralized exchange and using that as a custodian. But, and obviously the service provider cannot steal the money because they only have access to half of the key. And it's obviously more secure from the user perspective because now, even if the user is breached, there is like another service provider. But if that service provider is out, then you lose access to your funds unless you have a backup. They are usually operating in closed source. If you've worked with these companies, it's very hard to add like new assets and new features. Like it's really more of an enterprise kind of Web 2 solution, not really the kind of like open platform that we want in Web 3. And what we did with Unstoppable Wallets, essentially, we took the service provider part and we put something that is much more familiar to people in the space. A blockchain, smart contracts, and now if half of the key sits with basically the blockchain, with the validators, and you can split that across the validators as well. And then there's a smart contract which you can program, and you can now start to basically program on-chain wallets with whatever functionality that you want. And obviously, as long as the blockchain lives, like there's no situation where the blockchain goes offline and you lose access to your funds. The problem with this approach that we had, and it almost killed it, is that MPC requires pretty heavy-duty cryptographic building blocks. And we looked at all of the threshold ECDSA, basically the MPC algorithms to do this kind of thing. And we tried to extrapolate how that would run on chain, and it would completely break our network or any Cosmos network or any EVM network for that matter in existence. It's just too expensive, it won't work. So we did the kind of stupid in retrospect thing of actually building our own algorithm and rolling our own. It took us a while, but after a few months we actually got something which is very, very useful. So we built a new threshold ECDSA protocol that is on-chain friendly and that can run inside of a smart contract. If people here are from like the ZK area, I like to correlate this. Like this is kind of like analogous to how in ZK, you know, it's very, very inefficient to use like normal symmetric ciphers or hash functions. So there's this effort to build like ZK prover-friendly hash functions. So this is in a way similar. Like it's very, very slow to run this kind of cryptography on chain. So we had to kind of, with that in mind, come up with a solution that is friendly on chain. It also has other benefits like robustness and fairness. Basically, it's much more resilient than usual multi-sig wallets. And to be clear, this is not for secret, or this is not just for Cosmos. This is meant to basically be a cross-chain mechanism to sign and control wallets on any chain. The best analogy here is that unstoppable wallets are kind of like a building block to do cross-chain account abstraction. So account abstraction is this idea of smart contract wallets on Ethereum. Here's an idea how you can do something that can work on Ethereum, Solana, Cosmos, Secret, whatever you want. And this is an example where we basically have a smart contract wallet on Secret, but you sign it with, you sign transactions with it on Ethereum, and that was the first example where we got it to mainnet. All right, so I think one point to drive home is that these smart wallets, they're programmable completely. And we think there are many use cases that you can build and use them for, and we implemented two. One of them is obvious, and the other is less obvious, just to show that their expressible power. So the obvious one was to do basically a multi-sig wallet. So you need 5 out of 8 people, 7 out of 10, whatever you define when you launch the wallet. But you also have a spending limit. In this case, we put like, just as an example, like a 1 ETH spending limit. So basically, when you try to sign a transaction, when users are trying to sign a transaction, the contract verifies that they get enough signatures and that it actually parses the Ethereum transaction, and it would only co-sign it if it's less than 1 Ethereum. And you can come up with schemes that are much, much more elaborate than this. But I think the cooler use case, because that's not something that people think of when they see this for the first time. We didn't think about it when we started. In crypto, we always operate in this scenario where we move assets. We don't move private keys, we don't move wallets. It's always that those are static, and you move assets from one wallet to another. But there are many use cases and many markets that actually operate on the wallet level. They don't operate on the asset level. So if you think about things like, if you lost money in FTX, right? And you have a claim. And now there's this trust, like pen and paper based, like over-the-counter markets where people are selling their claims. Basically, they're selling their claims to get some immediate liquidity. What if you could find a trustless way where I could actually sell my wallet, which may have eligibility for like an FTX claim, in a way that I provably revoke my access to that wallet, and the buyer gets it. And with this mechanism, you can actually do that. Another use case is VCs. Often VCs buy into like SAFTs and illiquid deals, and again, there's a huge over-the-counter market for that. So again, if like a VC wants to get out of like an illiquid position, they can here use this mechanism to sell the wallet and not their assets. There are many other use cases for this. I think the point is to get developers to actually try to think what more can be done. One last example, which we didn't develop, but I do want to touch on, is what I consider unruggable DAOs. In my opinion, one of the biggest shortcomings of DAOs today is that at the end of the day, holders vote on whatever, but usually the actual power, the actual treasury and funds, it resides at a very, very small committee of several people. And those people can technically listen to the DAO or not. They can do whatever they want. So what if you can have a smart wallet like this, where there are specific rules that the community sets in a smart contract on how the DAO can actually spend their funds? And maybe this is being composed with another contract, a voting contract for the DAO, such that if ever, for example, the DAO wants to do something bigger, like maybe make a really big spend that requires the entire vote of confidence from the community, so maybe that contract basically absorbs information, like voting results from another DAO voting contract, and only if and only when that happens can the multisig actually spend the funds in that way. One less detour, because this is probably of separate interest. Like we had to put fairly deep cryptography into CosmWasm and into Secret to make that happen. One of them was put in additively homomorphic encryption, which basically gives you the ability to do certain operations over encrypted data on chain, but not all of them. A, this is a first, but B, I think this has potential and use cases that go beyond just what we're talking about today. Like one example, you can do encrypted voting contracts using this mechanism, completely irrespective to the wallet thing. And the last point I'm going to touch is everything I talked so far is like there's code samples, there's research backing it, security proofs, all that, but it's more or less POC and research level. This is different. So this is basically something we deployed in mainnet a few weeks ago. We call it Secret VRF. It's simply a way to consume randomness to your application or your chain in a very unpredictable way and do it on-chain. There are off-chain solutions to do this, but this is the first on-chain example. And right now we have APIs to all other IBC and Cosmos chains, and we're working on an EVM version as well. So yeah, I'll open up for questions. Most important takeaway message is privacy is not just normal, it's not just important, but it's really also useful. Hopefully, if anything you take from this, then it's that message. Thanks.
Okay, thank you very much. We're running a little bit late, so we have time for one question. Anybody? No questions? Okay, thank you, Guy, then.
Thank you.
So now I would like to introduce to the stage our panelists from O1 Labs and Aleo, and Anna Rose from ZKV.
All right, so yeah, this is the last kind of piece of content panel before our lunch. To give a little bit of framing for this particular panel, we did this also last year. The idea with this was to introduce ZK projects to the Cosmos ecosystem, but also kind of get a sense for folks working outside of Cosmos what it would take maybe to get into it. Maybe as a starting point, why don't we do a quick intro? Can you tell us a little bit about yourself and about the project? Start, Florian.
So I'm going first, I guess. I'm Florian. I do engineering for OF1 Labs. To give a bit of background, I guess OF1 Labs is the company that incubated Mina Protocol, and we remain still a very active core contributor to the protocol amongst other very capable companies. So Mina is one thing, and then we do have a second thing called Snarky.js, which is a very powerful TypeScript, sort of like CK toolkit, SDK, which allows you to write Mina smart contracts, Zero Knowledge smart contracts, and recursive circuits. So yeah.
Cool. And Daniel?
So I'm here representing Aleo, but I don't think I was necessarily outside of the Cosmos ecosystem. I used to lead the protocols team at Stakefish. And yeah, Aleo is you can call it a ZKL1. And yeah, fun fact, Matt Green was my advisor in grad school, and so I'd known about Aleo and its paper, Zero Knowledge Execution, for a long time, so yeah.
Yeah, so, I mean, a lot of the work I do is very close to it's very much in the ZK ecosystem, but you might be a good person to speak about this. You moved a little bit from, you had been very active in Cosmos. What's the change like when you step outside into ZK land?
I don't think I necessarily left Cosmos, but I did rage quit my last company. So. Oh. But I think, ZK, so I had actually been a part of, I guess, like the ZK. So I used to do bioinformatics research for a few years, and we used FHE a lot, and then we had to use ZK in that. But it's really exciting to see ZK find its sort of home in immutability, getting some on-chain verifiability, and the entire stack of composability and that blockchain offers. So.
Yeah, and maybe to give some description, like when we talk about the ZK ecosystem, it's sort of a collection of, sometimes it's like, it goes from like applications who want to build on ZK systems using privacy, all the way to like ZK L1s. And I think, a lot of the conversation last year, and something we want to continue, is this idea of like, how do these projects, either applications or the L1s, actually connect into the Cosmos ecosystem? Is there any benefit to doing that? I'm wondering if either of you have had thoughts on that, especially in prep for this panel.
Yeah, so it's a Cosmos panel, or like Cosmos event after all, so that's a very important thing. The Mina protocol, the Mina ecosystem is actively considering integration with other blockchains. For example, there's the Neil bridge, which is a trustless ZK bridge, which allows you to bridge the Mina state over to Ethereum. And that's just one bridge, and I guess potentially in the future there could also be more bridges to other ecosystems and chains, so that is one possibility.
Yeah, I think that's exactly right. Maybe another way to look at it is perhaps at the infrastructure service provider level, let's say like the validators. I think that validators have like this unique position to be able to see and support a lot of different blockchains. So Cosmos, obviously, and then Ethereum, Polkadot, Tezos, Solana, and then Aleo, for example. And I think validators can be a pretty effective bridge in both understanding the tech stacks of these different ecosystems, and then they're probably some of the best, perhaps, advisors in these blockchains in the ability to connect. So I think there's a lot that the L1s or even L2s have to learn from validators, and kind of seeing like, right, as an example, right, blockchains will rise and fall, some of them will disappear, but then the validators are mostly always there, they don't die. So.
Yeah, and you just talked about bridging to Ethereum, and that does seem to be a narrative that's grown in the last year versus, like, literally since last year. But obviously we're here in a place which promotes more like an IBC route. Do you think that sort of that look at Ethereum, is that almost like a bear market phenomenon and a look back? Is it sort of like, oh, we'll go to where it's still warm and not necessarily to where the future could be?
Yeah, so I guess my personal opinion is that ideally you would connect all the blockchains with each other. It doesn't matter if it's Ethereum or non-Ethereum. Certainly at the moment Ethereum is a very hot topic. That's where all the, I guess, capital is, where all the projects are. But I know that, for example, in the community there are people working on rollups in the Mina ecosystem, and they are exploring a sort of like layer 2 interoperability universe, which I can imagine would also then interact with Cosmos, look at potentially IBC, integrate with that. So I think there's lots of potential. But yeah, currently the hot topic is Ethereum, but I hope we can continue and then look at other blockchains, connect the overall blockchain world. So
maybe just to add on to that, it's interesting because when there are these like sort of connections or bridges to other ecosystems, sometimes it's like if we connect to Ethereum, then we hope that Ethereum devs will come onto Cosmos and then develop on our side, or maybe it goes vice versa. There's a pretty big like centralized exchange chain that we had been in like Cosmos. Some of the Cosmos folks had been in conversation with, and like the bridging was great, right? We could do that, and it was just a matter of how we needed to upgrade certain things on their end. But then the majority of the conversation had always become like, oh, what do you want out of this bridging? It's like, well, we want your devs, right? We want like Cosmos devs to come over to build on your thing, and then maybe like, so even though like I think Ethereum is great, and we're getting a lot of this sort of connection point, but then there's like the flows are going in certain directions, and perhaps like that bridging is that we want to like suckle on the teat of Ethereum and then have all of this like, you know, extra liquidity come in, but which is not a bad idea, right? But then I think, you know, we eventually are like kumbaya in the beginning, and then when someone gets big enough, they want to be their own king. And so,
yeah, I just briefly want to add to that. Yeah, I totally agree. I feel like most bridges are, even though they may be two-way, they are like mostly leading towards one side. So I think there's a lot of potential for a truly interoperable layer 2 world where like chains interact with each other, they benefit from each other, not only one central, I guess, chain, and just a very big, beautiful interoperability world.
I have a question that actually speaks to both projects in and outside of Cosmos, which is how do we get people building private applications? Is it like what, I mean, I think both of your projects have a version of that, but maybe even think past that. What do you think we need to get more people in? Because like that, like if you only have a small pool that's like moving in and off, like around bridges and still the same devs, you're fighting for a very small pie. So how do we grow the pie?
Yeah, so we have heard that in the previous talks. I think a very, very big important thing is user and developer experience, right? On the application level for the users, but also on the sort of like tooling levels for the developers. If we only have a very, I guess, like centralized minority that knows how to use these tools, then we will not have any more developers working with it. There's like an entry curve, a lot of learning you have to do to develop meaningful applications. So it's important to make that more accessible. Also on other chains, overall very accessible toolkits, easy to understand. So you don't have to be like a cryptographer or like only a couple of handful people that are already doing the same thing on 5 other chains and then just, I guess, copy pasting that over. So like opening up the developer experience, developer pool, and then I think users will follow. They will use these applications if they are good, which they hopefully are. So.
Yeah, I also think that ZK itself is not just a Web3 thing. As I'd mentioned, right, we were using it when we were doing just bioinformatics genetic sequencing research and just sharing data between labs. I think that opens up this huge opportunity of like the Web 2 world that has an opportunity to use like this tech platform that is going to be on blockchain. And I think a really good example is I don't think ZK is necessarily like a speculative value proposition that blockchains are providing that have ZK functionality. It's more of like a useful value. Like, for example, right, Bitcoin, some people hate it, some people like it. And so like there's like that argument that, oh, Bitcoin's burning down the planet. a lot of people use the same sort of argument with AI, you know, using massive GPU farms, and ZK is also using these massive GPU farms that eventually turn into FPGAs and ASICs. But then, right, like the argument, so for example, from the climate perspective, you know, the aerospace industry uses emits 9 times more carbon emissions than Bitcoin, but then people don't like vilify it, right, as they do with Bitcoin, because there's value that people have. But with ZK, I would say that's more analogous to the aerospace industry in that the value is not necessarily speculative in that, right, just like number go up, but then people are using it, right? Like people are using it in consortiums. We were using it in like sharing data back and forth between labs and FHE. There's like a lot of gaming applications, et cetera, ZKML, like hiding some of them and allowing people to be more comfortable with sharing their data to train these models. I think the key point is that ZK allows the Web 2 world to interact with this technology platform that is native to the blockchain, and that will, I think, naturally allow, let's say, clients to come in or different industries to also use this because it's a necessary component. And that special part is basically the rise of like these sort of POW style ZK miners that are going to have this hardware that's now much more efficient because so much money has gone into the R&D to develop them because, right, the value associated with these tokens, a la like what happened with how Bitmain was able to get so much money into R&D because the Bitcoin value went up and they're able to develop more efficient and effective ASICs. So
I want to kind of take a little bit of a step back to something you said earlier, which was about the languages. And so I know each project, I don't think you mentioned actually Leo, the language that Aleo developed. So there is this fragmentation happening a little bit in the languages. The ZK DSLs, I think I know at least 12, maybe more. And almost every blockchain will have its own, every ZK-focused L1 will have its own language. Do you think this complicates it being adopted into other ecosystems? Do you think that if we had maybe even on our side a bit more of a standard, that would help to get these ZK tools into the other ones?
Yeah, no, I mean, certainly. There's, like you said, plenty of DSLs. Some are Rust-like, some are like TypeScript libraries, not necessarily DSL, like what Snarky.js is. And I guess it can be confusing at first for developers getting into that. There's a lot to choose from. Not all do the same thing. All require, I guess, slightly different, like a knowledge of certain implementation details. So I think it would certainly be beneficial to just overall improve the developer experience. And that certainly includes the, I guess, DSL tooling layer, how to write applications, how to work with them, right? I mean, if you develop an application on one chain, you want to make sure that however you can transfer it to other chains. Right? You don't want to like rewrite everything every single day for every other potential use case. So I think it's certainly very beneficial to have a common ground. If it's not on the, I guess, DSL layer, then maybe on the, I guess, circuit representation layer, making sure that you can integrate with other stacks, other tool systems that includes testing and all that stuff. So
yeah, maybe I'm being naive, but I think that if there's a purpose and reason that people need to build these ZK programs, then you're going to have to just learn the language and suck it up. I don't think it's necessarily a problem that there's many different languages, but right, if there's a language that you need to learn to build a ZK program that you need to serve a particular application or purpose or initiative, then just learn it. Like just because it's like you have like this EVM compatible ZK stuff and it's like maybe it's not fit for purpose, but these DSLs exist for a reason because they are fit for purpose to build these ZK programs.
Maybe. I think what this makes me think of though is this idea, and I've talked about it a few times on different episodes, of like if you wanted to be private in a multi-chain context, what you're describing is each side would have to like be written in a different language. And I think that leads to a lot of vulnerability. And actually, I kind of want to even bring this to IBC and maybe also other bridging, but like, you know, wouldn't it be kind of cool? Like, I think IBC is cool because of the fact that it's this thing that everyone can agree on. Like, wouldn't it be cool if there was also a ZK language that was sort of agreed upon within maybe this ecosystem or like more generally? I realize this is a big ZK topic.
Yeah, maybe, like you were saying, maybe it's a standard. Maybe it's like the bridging like the communication standard, which IBC, I guess, can implement.
So, no, yeah, definitely. I think there's probably two different types of standards that you can think of. One on the very high language layer, like having the exact same language. And then I guess something lower, which may be the circuit representation, or it may also be the communication between proof systems. So that's also a big part. We have only been talking about languages, and they then compile to their own, or like utilize their own proof system to do the proving of their proofs, but they can't really necessarily, I guess, interact with each other on the proof system. So if you have a proof on one chain, or like from one toolkit, then you have a proof on the other toolkit, what do? You can't do anything with it. So you essentially lost all the benefits of ZK if you have two different proofs. So I guess it would also be beneficial to look at the integration level of proof systems, and I'm not a cryptographer, so I don't know how to do that, but I think that would also be beneficial.
Or maybe I don't want to keep shilling like validators, but like, I mean, maybe it's like, right, because if there are these different ecosystems, a lot of these different ecosystems share the same validators, right? There's obviously like the usual suspects, but then maybe if they are the same, maybe they are this sort of like semi-trusted party that is able to communicate what needs to be communicated between those different ecosystems. But yeah.
Yeah, I think this is an idea that's still, at least for me, still kind of developing of how, and we had talked about it, like privacy on one chain, privacy on another chain, often coming in and out, like going over a bridge just automatically removes the privacy. We had talked about, like, would there be private bridges possible? Could IBC be made private? Could it, if it incorporated some, and maybe it doesn't need the language so much on either side, but yeah, I do think there's a conversation here. I feel like we should have an IBC expert up on the stage to help us have that. But okay, another question, speaking of IBC, is do you ever imagine implementing IBC? Could Mina or Aleo be could you tap into this directly? Or are privacy systems built so differently that it would be hard to do?
Yeah, I guess we officially do not have any plans at the moment, but I can imagine that there are many community members building like compatibility layer 2s and all that. So I could certainly imagine that they take a look at that and at least take that as an ideal. Certainly build up on that and maybe integrate with it, but I guess we currently don't have plans in regards to that. We are currently, I guess, more focusing on the approach that I mentioned.
And just to clarify, what you were saying there is like you could have a roll-up on your system that would then have IBC integrated, potentially.
Yeah, I mean, potentially, right? And then that could also integrate with other roll-ups, other IBC-compatible chains, and then you could do that again and just keep going.
I think if there's a very specific purpose, then the bridge should be built. Like if there's just like a bridge to just have a bridge, then like as he was saying, like what direction is the things going? Yeah. But I mean, the ZK prover ecosystem, like these POW style ZK miners, they're free agents, right? They can provide their proving services to any chain, right? If the Cosmos ecosystem has the ability to kind of like use that, then right, that's just you're just sharing infrastructure providers, and then therein is like the closeness that you can have between the two ecosystems.
That's actually, that whole world, like what that will actually look like, I've obviously heard a few times it described, but maybe we can just talk a little bit about it, which is you have the sort of transactions and the blockchain happening over here, but the proofs are potentially generated in a different setting, often by a validator-like entity. I know Aleo's built quite a lot around that.
Yeah, just for some context, Aleo is like this hybrid POS, POW style system where the POS is just the block building and consensus, And the POS stuff is, the POW stuff is just like ZK mining, right? You do your off-chain proofs. And it's fascinating because, right, you're getting to see these two different ecosystems, these infrastructure service provider ecosystems interact. So just coincidentally, right, like when I was at Stakefish, our sister company was F2 Pool, which is like the largest Bitcoin mining pool at the time. And so I was quite familiar with both of the infrastructure providers on both sides. And so now we're beginning to see, because I'm helping set up the validator and prover ecosystem in Aleo, we're beginning to see like all the infrastructure providers kind of take a look in. And what I think is the most fascinating is that you're going to begin to see like these sort of hybrid organizations where you have both the validators take on like the ZK mining capabilities and the ZK miners take on the validator capabilities. But I mean, I've seen both sides, and I honestly think that it's much more difficult to take on the validator responsibilities. So I see more validators taking on, you know, the plug and play ZK mining stuff. But yeah, I think it'll be interesting to see the ecosystems interact.
Yeah, I also, Mina has something like that as well.
Sorry,
I blanked for a second.
Oh, no worries, no. Yeah, we have something called snark workers, which are essentially like a prover infrastructure network. They are providing the proofs for transactions, right? So if you send a transaction, to give a bit more of background, you send a transaction, it's being proven using a snark worker, and then recursively, I guess, merged together with other proofs. And then you end up with one main proof, sort of like testifying the correctness of the entire chain. So we do have something called snark workers, which is that network of provers doing that proving. And then there's something called the snarketplace, very snarky names, where you can where you have like some incentives, right? If you run a snark worker, you generate a proof and you get some mina for it. So.
Yeah, sounds good. Cool. Well, I've reached the end of my questions, but I do want to open the floor up for more questions, if anyone has any. So we can... Oh. Sorry, my bad.
Hello. So at Penumbra, we do IBC permissionlessly to everywhere, but of course IBC is transparent. And one of the things that we've been trying to think about is how do you manage to do private IBC without having a problem of like, if one of the counterparty chains misbehaves, then you leak you could potentially leak you could get contamination from a counterparty chain, because ordinarily in IBC you have like circuit breakers. But doing a circuit breaker with an encrypted or zero knowledge IBC connection seems tricky. I'm wondering if you have any thoughts about like what directions those might go in.
We need Jack Zampolin to come in.
Yeah, I feel like you're the expert on this.
I don't know if this is answering the question, but like Aleo has like this program registry that allows for differential privacy, and if there is a need for a certain counterparty on another ecosystem that does require some selective information, then that can be opened up. But did that? Yeah. So.
Okay. Yeah. Maybe we should chat offline about that. I'm curious.
Yeah, I mean, you're certainly the expert on that.
Sorry, it's a super niche question.
It's a great question, and it's like an important question to actually talk about. That's what I think I was trying to hint at, that vision. But I think maybe, I don't know if we are the right people.
I feel like we need to solve this problem in some kind of way, whether it's through like homomorphic encryption or MPC or something, so that we can like contain malicious counterparty chains in order to have like real private IBC that works properly.
This is a question, actually, I'm going to ask you this, but like, have you, and this is maybe the counter IBC argument, would it be easier, better? Do you have more flexibility if you actually do a bespoke bridge that uses one of these techniques? Is it harder to try to shoehorn it into an IBC setting.
I think probably the thing that we're talking about would not be IBC. It would be another inter-blockchain communication protocol.
Okay.
But I don't think it would look like the protocol that already exists.
So it is different, yeah.
Yeah, and then you have these problems of like if every chain has its own shielded pool with its own proving architecture, then how do you do proofs that like translate between like you're using Plonk, I'm using Groth16 or whatever. Like what do you do? I don't know.
Slap a standard on it.
Try to get a standard.
And then you have 16 standards instead.
I mean, I think IBC as a standard for this ecosystem is incredible, given how early it was thought up, and I think like in the ZK space, it's not just ZK DSLs, it's proving systems, it's like even like circuit size techniques within a proving system, because you have things like Plonk, but then you have like variations on Plonk. Since then, Halo 2 as well. Yeah. Cool. Well, any other questions? Oh, maybe one more? Right there?
Hey, this is a significantly more basic question. So, like, you mentioned about talking about kind of like Bitcoin, and you talked about aerospace, and kind of just like how there's some like the ways that ZKs actually is quite useful for getting end customers outside of Web3. I wondered, like, what do you think are the most like suitable end customers for ZK, like, and how do we approach those better?
So I think when you say customers, I think the way we tend to talk about it is like use cases. So like one big one would be like ID, ZK ID, ZK ML. So this is where using a blockchain is sometimes really useful for immutability and consistency. But I think that at least in the ZK-ML case, there's already examples where you're using ZK to prove that something is accurately done within a modeling training and stuff like that, like making sure that the data that was fed was correct. That doesn't really require a blockchain anywhere. That's just using ZKPs. So maybe, yeah, to speak on that, zero knowledge proof technology started in the late 80s. And it was sort of theoretical, kind of under the radar. People did try to use it for passwords, I think in the early 2000s. But what happened was like you melded it with blockchain, all of a sudden all this like excitement, maybe financial incentive, a lot of money poured in, libraries got built, mindshare was grown. And so it's grown, like all the ZKP systems that we know today, a lot of them were developed in the last 5 years. The common proving systems, the Snark, the Plonk, the Snarks actually, the Snarks, the Plonk, the Novas, but yeah, like what's funny is like it accelerated through blockchain, and now because these systems are so good, you can start to see them spilling out into these other realms. Sometimes tied still back to a blockchain, sometimes not. But yeah, I'm very excited to see where this is going. Like the topic of ZK outside of blockchain is like fascinating and not super well spec'd out yet. The only one the one I can point to right off the bat is this like machine learning, like showing that the data was correct. I don't know if you guys have other examples.
Learning, like that stuff, and I do think that blockchains, or like the cryptocurrencies and their associated blockchains. Particular use case here is that you have like the speculation and then the value increases, and then you're able to get a lot more money into the R&D that goes into developing more efficient and effective ZK hardware. Because if the end goal is this like ZK ASIC, or some people call them like ZPUs or something like that, then you have like this what was not possible in the 80s or the early 2000s. We now have more accessible and potentially even commoditized to serving whatever different use cases there are. Bitcoin is, I think, the perfect example, right? We were able to just do it on like crappy hardware. Obviously, the difficulty went up, but then we have very fine-tuned, efficient, and effective hardware that exists now and not later because Bitcoin's value went up and they were able to use that money to support it. So.
Yeah, just very quickly, just to generalize that, I think there's probably a lot of potential in the Web2 world when it comes to proof of model, So for example, CK learning, that's a proof of model. How do I know that the thing you're giving me is like truly that awesome AI thing, and you didn't do it yourself? That would be awful. Or maybe things like, how do I know that you're really offering me like the best price on like a flight, website comparison? How do I make sure that you're not artificially pushing the price for some reason potentially? Or maybe peer-to-peer interactions with users. How do I know that you are who you are? That could be chats, potentially even games, if the technology is advanced enough. So.
Yeah, I think that the use cases have been expanding in the ways of using these things, and I think there's a lot of uncharted territory. So there's actually a lot of space for creativity and trying to use them in certain cases, seeing if it works. I do want to just mention like some other cryptography that also is starting to be like, or has been for a while, but tied in with ZK. So sometimes people use the term ZK as this blanket term for advanced cryptography. So you have things like fully homomorphic encryption or multi-party computation. So what we are seeing more and more is like these systems trying to incorporate pieces of those as well, maybe combining them. And there's going to be some very powerful, interesting things that come out of it, I think. I think it's fair to predict that. All right. Cool. Thank you so much for staying for this morning session. We're going to break for lunch. And thank you to our panelists for the, External Privacy into Cosmos panel.
Yeah, thank you.
All right, so just a note before you get up for lunch, just one more thing.